Now, when we talk about myth number 3, this is regarding the cooling system of the wind tunnel. So passive versus active cooling. First of all, I like to start that the heat inside the wind tunnel is being generated by the friction of the air that's running around this tube, and not from the electrical motors itself, which sometimes comes as a misconception from potential customers. And now, before we talk what is better or not better, or what we prefer, I'd like to show you what is the difference to those who might not be familiar with this topic. So first of all, there's two main types of cooling of airflow inside the wind tunnel. The first one on the left-hand side, you can see the passive one. It's when the hot air is being exhausted through hatches and cold air is being drawn into through other set of hatches, thus exchanging part of the hot air inside the wind tunnel with the air in the atmosphere. Now on the right-hand side, you can see active cooling tunnel, which is enclosed loop that has heat exchangers. Usually they're positioned in the corners in the turning vanes of the wind tunnel that turns the airflow. And this is basically a heat exchanger filled with cold fluid that's constantly being exchanged. And when the air is passing by these turning vanes in the corners, it's being gradually cooled down. Now, once we look at the power figures of these two systems, so we have the actual benefit of having exactly the same tunnel in both configurations. Our wind tunnel in Kiev, it was initially designed to have a passive cooling system. But when the project was resumed, the client decided to upgrade due to the fact that there's a lot of residential buildings had been built around the tunnel since its original build date. And by doing this, we had the opportunity to actually compare these two systems and the power, the total power of both systems. So if you can see the numbers, then it's for the passively cooled wind tunnel at maximum speed. It was expected to require about 1 megawatt of power, and by taking away this passively cooled system, by taking away these unnecessary restrictions and resistances, what we achieved is the decrease by almost 30% in tunnel power. So with the active cooling system, the maximum power is just 800 kilowatt for the same speed. Now, you obviously need to consider also the additional cooling power from the active cooling system, from the chillers, from the pumps, etc., that comes on top of the tunnel power. But the main point that I wanted to focus on is the total power at the end. So in both these situations, you can see that the total power is roughly the same. So this has come from our simulations, and actual real-life situation shows these power figures to be exactly the same. Now, further, I'd like to discuss a few of the passive cooling system downsides. So, for example, if you have the wind tunnel in a cool environment, let's say it's Norway, it's winter time, everything's great. Your outside temperature is let's say plus 10 degrees Celsius. Inside, you're gonna be able to achieve even 15 degrees, which is less than you would need. So you can easily achieve comfortable flight temperature for professionals, for beginners, etc. Now, when the summertime comes, and now we all see the changes in climate and the temperatures that even in Norway it reaches plus 30 degrees Celsius in the summertime, and you know in Western Europe it goes up even to 40 degrees Celsius. Now, if there would be a wind tunnel in such conditions with passive cooling, then your inside temperature would be even 5 degrees higher than it is outside, because you're not able to exchange all of the air. So at plus 45 degrees, not even talking about technical issues that can arise there, it's even uncomfortable and possibly unsafe for flyers to fly at such high temperature due to the load that's being experienced by the flyer and the possibility of actually going unconscious in such high temperature and load. Now, once we talk about the noise, so the wind tunnel inside creates quite a lot of noise because there's fans which create noise, and once you open a hatch, it would be the same as having music blasting at max in your well-insulated flat, and then you open the window and suddenly all your neighbors hear your music. The same happens here. So once you open those hatches to cool the air, all of this noise is polluting the area around your wind tunnel. So imagine it being close to a residential area, or let's say in a shopping mall. So all this discomfort is being transferred to your customers, while with active cooling system you don't have such an issue because the whole loop is enclosed. Another issue that must be considered is also ingress of particles and sometimes even birds if proper measures are not taken. And this comes down to two main issues. The first one being that you need to clean your wind tunnel more often. All the dust and dirt is going to settle on your components, and especially on the glass, which you want to keep as clear and as clean as possible all the time, because it is your main focal point. And also the dust and smaller particles that can ingress the wind tunnel actually pose a danger to your customers. So once you take the proper measures to not allow these particles to come in, this definitely is going to be another point of resistance for the airflow, which in turn will increase the power consumption of your wind tunnel. Now, the last but not least issue I'd like to discuss is the disruption of the airflow. Now, depending on the way the air exchange hatches are designed, this will give you a smaller or larger disruption of the airflow. And again, when you're designing a wind tunnel, you want to make it as smooth, and all the transitions between the components, you want to make them as smooth as possible. But then you're introducing hatches, which are actually stepping inside the airflow and disrupting the airflow. So at the end, this decreases the quality of your airflow, and it actually increases the power consumption for the machine because of the increased resistance. So to summarize, the four main downsides would be the regulation of temperature, so that's the comfort for your customers. It's the airflow disruption. It's also the possibility of ingress of dust and other particles, and at the end, it's overall comfort for your surrounding area due to the noise.